everyone. So in this lesson, we're going to be talking about right triangle trigonometry. And specifically, we're going to talk about three really important trig ratios that you're responsible to know. And we're going to talk about how those trig ratios can be used to find the missing sides of a right triangle. Okay, so these problems will always involve one of the acute angles of a right triangle. And typically that angle is labeled with the following symbol. Okay, so that symbol I just drew, that's called theta. Basically, it's just a variable that's used to solve for an unknown angle. Okay, so now we're going to talk about how the three sides of the triangle relate to that angle. Okay, so the side across from theta, we call that the opposite side. Okay, the side next to theta, that's called the adjacent side. And then everyone knows that the side opposite the right angle is called the hypotenuse. Okay, so now we're going to go over our three trig ratios. So the first one is sine of theta, which is abbreviated SIN. So sine's ratio is always the opposite side over the hypotenuse. Second ratio is cosine, which is abbreviated COS. So cosine's ratio is always adjacent over hypotenuse. And then the last ratio is tangent, which is abbreviated TAN. And tangent's ratio is opposite over adjacent. Okay, so those are three trig ratios that we're going to be using throughout the lesson. All right, and we do have a way to remember those three ratios. We remember them using the following. All right, this is something you might have heard before. It's called SOHCAHTOA. So it's written like this. So sine's ratio is always opposite over hypotenuse. Cosine's ratio is always adjacent over hypotenuse. And tangent's ratio is always opposite over adjacent. Okay, so it's pronounced SOHCAHTOA. So let's look at an example. Okay, so here we're given the right triangle in the diagram below. What is the value of x to the nearest foot? Okay, so we're going to look at our acute angle, which is 40 degrees. So the side labeled 14 feet is adjacent to the angle. And x is opposite the right angle, so we know that's the hypotenuse. Okay, so I'm going to write down SOHCAHTOA on the side of my paper. All right, so we have the adjacent side and the hypotenuse. So that's going to involve cosine's ratio. So we're going to set this up as cosine of 40 degrees equals the adjacent side, 14, over the hypotenuse, x. All right, and don't worry about cosine of 40. That's just a number that we're going to get from the calculator. Okay, so I put this over 1 to set up my proportion, and then I'm going to cross multiply. So we get x times cosine of 40 degrees equals 14. And then to get x by itself, we want to divide both sides by cosine of 40. Okay, so from here we're going to put this in our calculator. So first we want to make sure that our calculator is in degree mode. Okay, so what you're going to do is when you turn your calculator on, you're going to hit the mode button, which is right next to the second button, and it'll bring you to this screen. Okay, so you'll notice right now my calculator is not in degree mode because degree is not highlighted. So to get it in degree mode, I'm going to scroll down to where it says degree and then hit enter. So once degree is highlighted, now your calculator should be in degree mode. Okay, so now we can quit out of this screen. And now we want to type in 14 divided by cosine 40. So I'm going to do alpha y equals. So we got 14 divided by cosine of 40 degrees. Okay, so we get x is approximately 18.3. All right, so in this question, they wanted the answer to the nearest foot. So that would be choice C, 18 feet. All right, let's look at another example. Okay, so in this example, in the diagram below, a window of a house is 15 feet above the ground. A ladder is placed against the house with its base at an angle of 75 degrees with the ground. Determine and state the length of the ladder to the nearest tenth of a foot. Okay, so they want the length of the ladder. Okay, so here's the ladder leaning up against the house, so we'll call that x. That's what we're solving for. So 75 degrees is our acute angle. So 15 is the side opposite that angle. And x is opposite our right angle, so that's our hypotenuse. So again, we're going to write down SOHCAHTOA on our paper. And then we want the ratio involving the opposite side and the hypotenuse. So that's going to be sine. So we're going to do sine of 75 degrees equals opposite 15 over our hypotenuse, x. Okay, so again, we're going to put this over 1 and then cross multiply. So we get x times sine of 75 degrees equals 15. So to get x by itself, we divide by sine of 75. And then from there, we put this in our calculator. So we're going to go back to our calculator. Hit alpha y equals to get our fraction. And now we're typing in 15 divided by sine of 75 degrees. Okay, so we get approximately 15.5. Okay, so the ladder is approximately 15.5 feet. All right, third example. A tree casts a 25-foot shadow on a sunny day. If the angle of elevation from the tip of the shadow to the top of the tree is 32 degrees, what is the height of the tree to the nearest tenth of a foot? Okay, so this time we're solving for the height of the tree. So we'll call that x. Okay, so again, 32 degrees is our acute angle. So x is opposite that angle. And 25 feet is adjacent to that angle. So I write down SOHCAHTOA. So the ratio that involves the opposite side and the adjacent side is tangent. So we do tangent of 32 degrees equals opposite over adjacent. All right, so we're going to cross multiply. So we get x equals 25 times tangent of 32 degrees. Okay, and then again, from there, we're going to put it in our calculator. So this time we have 25 multiplied by tangent of 32 degrees. Okay, so that gives us approximately 15.6. Okay, which in this case is answer choice B. All right, so those are 3 examples involving SOHCAHTOA, or right triangle trigonometry. All right, I hope this was helpful. I will definitely be posting a worksheet for you guys to practice some questions along with some worked out solutions for you guys to try on your own.